Hello, everyone. Hello, Martin. Hello. Welcome, Denmark. Hi, Yordis. Happy that you joined. Let's give like 2 or 3 minutes for those people that might be a bit late. In the meantime, for those who don't know me, my name is Oskar Dudycz, and I'm working as a developer advocate at EventStoreDB. And today, I'm going to present you how to create a simple but complete application using Node.js, TypeScript, and EventStoreDB. We will also use MongoDB for read models. So unfortunately, nowadays, the world goes quite crazy. So happy that you joined and you're here. So maybe let's start. This will be really hands-on experience. We'll start with the short introduction to explaining the basic concept, and then we'll be diving directly into the code base. Hello, Adam. So let's start with looking at that old photo. And why am I showing you this photo and who's there? For those that are box fans, you for sure know that at the top there is Muhammad Ali and at the bottom there is Sonny Liston. This is really old photo and it was taken in 1965. This was a fight for a heavyweight championship and it lasted like 1 minute and 44 seconds. So much shorter than my introduction. And why am I showing you that photo? Because this photo is an excellent example of what's an event. So event gathers a specific business information or in general information. In this case, we know that Muhammad Ali won and Sonny Liston lose. Event happened in the past. And we know the specific time at which it happened, and we cannot change the past. The result of the fight, it won't be changed. And what's also quite important or really important is that even though event gathers is a fact, is something that we cannot change, it gathers specific information, but it can be interpreted in multiple ways. The same fact, like the result of that fight, the interpretation would be totally different for Muhammad Ali and for Sonny Liston. Of course, if Sonny Liston at that moment could interpret anything. Another thing that I would like to explain to you is event stream. That's another important term in the event sourcing and in general event-driven architectures. So event streams is an order sequence of events. If we have a look on example stream that you see on the screen, a shopping cart, then event stream is a history. It's a story about the specific object. In this case, a specific user shopping cart. So as we see, there is a shopping cart event opened, product added to shopping cart, and product removed from shopping cart. So as we see, this is one by one showing the history of the object, so all the business operations that were recorded for it. And event stream, we can have multiple streams. In fact, event streams is a representation of the specific entity. So it should be almost in 99%, it will be like we will have as many streams as we have entities. So shortly, if we compare that to the traditional approach, then we can think as a in event sourcing terminology, event stream is a whole history that happened for the specific object with specific ID. And the important thing about event source systems, at least in majority of them, is that you can even see the whole history of the operation that happened in your system. So as you see, we have two streams here, but in fact, all of those operations happened or were recorded in our system in specific order. So thanks to that, we can know which shopping cart was opened first and which was the next one. And let's go now to the event sourcing architecture. No, this is not event sourcing architecture. In fact, there is not something like an event sourcing architecture. So maybe that one? No, that's also not an event sourcing. So if you see such pictures where you see a lot of messaging systems, queues, and a lot of diagrams, then 99% sure you can be that this is not event sourcing. So what it is, event sourcing? Event sourcing, the name event sourcing comes from the fact that in event sourcing, events are source of truth. So after each business operation, we are recording new fact. So in our case, the new business event. So on that screen on the left side, you will see the events that will be happening for the specific shopping cart. And on the right bottom, near to our favorite Dragon Euro, there is like a classical representation. So let's say that we opened our shopping cart and then we added a new item, for example, Cyberpunk. But then we decided that no, we won't be playing Cyberpunk because it has too many bugs. So we will just go back to The Witcher and play with that. And after that, we confirmed the operation, etc. So let's look again. Typically, when we were creating a new record, then in database, it would be just a new record in the product, in the shopping cart table or product items table. When we are adding new information in event sourcing, always new information, new fact means that there is a new event. In classical approach, we will be just updating a specific field or adding new specific record. In this case, we are just increasing the product's count. And after removed product, then as you see, there is no difference between the initial state and the state that we have after removing the product item. So we lose already a business information because we don't know whether something happened or not, because we see that just the flattened state. And that's one of the most important aspects of event sourcing, is that you are not losing any business information, because you can see the whole history. And even as a developer, you can get those events from event stores and then just replay them and play with that like I was doing. So back and forth to understand what has happened. So diagnostic is a key feature also. So let's have a look again, because you could say that, yeah, but we can add a new table and we can have a bigger granularity. So now, instead of the nice picture, you will have in the middle the data of event. So cart initialized will have information about stream ID, which, as you can see, is the same as the record ID, so or the primary key in the classical approach. Position is an order, is a information in which order the event happened, so we can put a timeline into our events history. Then we see a timestamp, so where it was happened, and then specific data. And so if we added product, then we are adding new item to product items table. But if we removed this item, then again, as you see, adding new table is not helping at all, because we also losing this information. And even when we add it, etc., then we have a bit more information, but it's still not comparable to what you can have in event sourcing. And nowadays, storage is quite cheap, but information priceless. So how event sourcing is working, in fact? So when we are getting request or comment into our application or our API, then the first thing that we are doing is we are retrieving all of the events that were recorded for the specific entity. So for example, all events that happened for the specific shopping cart. After that, we are applying this event. So as you see, at first, when we are opening shopping cart, then we are getting the empty shopping basket. When we are adding new product item, then we are updating the product items list in shopping cart. If we remove, then we are also updating the current inventory state. And at the end, we are getting the current state. And from that moment, there is no difference between the classical approach. We are also calling the business logic. And after that, as a result, we are storing event. So that's the only thing that is different from the classical approach. So all the business logic, etc., can be run exactly the same way as you had previously. But you have this benefit that you still have all of the business information. You are not losing any data. You can get even more insights from your data and even find new business model based on the historical data. So how can we store events? We can store, for example, in a relational table, because event sourcing doesn't say anything how we are storing events. However, storing events in a relational way is fine, but we can at some point reach the limit of the relational database, because as we know, relational databases are great, but they are in fact good enough for majority of cases. But if we have the storage, dedicated storage that was designed in a way to just store events, then we can have more optimization. Like binary format is, of course, we can it can take much less data than the raw JSON, etc. And as we know, what's killing the relational approach is the random updates and random reads that relational database needs to support. But if we design a storage that is dedicated to getting all of the events, so for example, keeping all of the events for the specific stream in the same place, then we can benefit and have a really good performance. And that's how EventStoreDB is working. So it is database natively built for storing and getting events. So we are not doing much besides that, but we are really good at it. So we are 15 minutes already left, so we can dive directly into the code, because as I promised, this will be a really hands-on experience. So far, there is not much code there, but we will be gradually building our application. So let's start with defining some events. Let's see how we can express events data in our code base. We will be modeling the business case that I showed, so shopping cart. The first event will be the shopping cart open, which will have the ID of the shopping cart, the person for which we are opening shopping cart, and some information when we open the shopping cart. Then the next event that we would have is product item added to shopping cart, which again have the shopping cart ID, because we have to know for which shopping cart we will be doing this operation. And it has also product item, which for our simple case will be just the product ID plus the quantity. So how many products of the specific type we are getting into our shopping cart. Because maybe we would like to buy 2 cyberpunks, because maybe the second would have less bugs, so we can have more than one. And the next one is product item removed, so the one that you saw, and the shopping cart confirmed, so the event that will be marking our shopping cart as confirmed. We can start a payment process, the shipment process, and take it from there. This event will just end life of our business process. So don't worry about this highlight. It means that we haven't used that type yet, but we will do soon. So as you see, this is a simple representation in TypeScript. So basic typing. And the final thing about event definition, we will create also a union type that will group all of our events. So as you can see, I ordered also those events in the order that they are typically happening. So we can also, even by the type definition, it already has the benefit of being both technical definition and also gathering the specific business information, which is the key factor here. But like I said, events are fact, and they should not be mutable. So how can we do in TypeScript and make our types immutable to make sure that we won't even have the physical chance of updating them in the code, even by accident? Then TypeScript has a useful built-in feature type read-only. And this read-only type will make that impossible to update data that we have in our event. So let's say that our event, specific event instance would gather such information. So client ID, shopping cart ID, and some date. And if we have this read-only type that is wrapping our type definition, then if we try to change the value, for example, client ID, then TypeScript compiler will help us and tell that you cannot assign client ID, etc. So just disclaimer, for a long period of time, I was a TypeScript hater. But when TypeScript became a full ECMAScript compatible, and it's in fact just extension that is helping to shape the type system and make our code predictable, then I decided that, yeah, I think that TypeScript is nowadays a really cool language. And especially if we are doing event sourcing or domain-driven design, where we would like to have the chance to trust our types, then TypeScript is in my opinion, really good matching. But as you see, we define events, but as I said, there will be no revolution in our code base in general. So we will be still using the entities, because we still, to make a business decision, we still need to have the current state of our stream. So we need to still define the entity and all of the data information that it has. So as you see, it has ID and client ID, which will take from the initial event, so shopping cart opened. Then we have a list of product items that we will be building. If we are getting the product item added event, then we are adding item to here. If we removed, then we are decreasing either count or removing the whole product item. And we also have opened at. This is required because we expect that first event that will come will be the shopping cart open, and it will always have the information when the shopping cart was opened. And at the end, we have confirmed, which will be filled only when we got the shopping cart confirmed event. We also have shopping cart status, which is opened, confirmed, cancelled. And we can TypeScript also allows to define the union enum definition. So, for example, that closed means that it's either confirmed or cancelled. So, how to get the current state from the set of events? So, to get, as I mentioned, we will be taking all of the events and then taking one event after another and applying that and building the current state. So let's define how our apply method would look like. The apply event method, it's also quite often called when in event sourcing. It's just a handler that is taking the current state. It can be undefined. For example, if that's and if no event was applied, or we are getting the current state, so further on that we applied. And we are taking the event, and as a result, we are returning a new state of the same entity. So it's just a transformation or application. So we are taking the current state, applying new event, returning new state, and on this new state, we are applying again the next event. By the way, feel free to ask questions. I might not be able to answer them as I go, but for sure I will try to answer all of that at the end. And Darek, for your question, yeah, I will put all of those code samples on GitHub. In fact, if someone is sneaky, you can already find PR in my Node.js examples. There is a PR with all of those samples. But let's not spoil and let's not break the fun. So how to run those apply events on our aggregate? So we will define another type, stream aggregator. Stream aggregator will be a method that will take this when, which is the apply, the definition, how we'll be applying all of those events that we recorded into our state. And we will also get events from the, for example, from the event store. And for all of those events that we got, we will be calling the when method one by one. And let's go how we will be applying that. So the current state at first will be undefined because we haven't applied any event. Then, as I mentioned, we will be doing the for each, a simple for each. We will go one by one through all of the events and call when methods. So as you see, because we define our shopping cart also as a read-only to not change that accidentally, then we are just doing a simple aggregation. Taking first event, taking the undefined, then returning updated state, and after that, taking the step and applying the new event. So it's simple as that. If it appears that that after this application, our state is still not defined, because, for example, we didn't have any events for some reason in our stream, then we will be throwing exception. So in those examples, as you might notice, I'm using quite functional approach, but I won't be going fully railway. I won't be returning errors in all cases because that could take us too long. But if you like functional approach, then in this case, you would probably return either entity or this error state. But let's move on. So you might notice that there is a bit weird syntax. So we have, in fact, first method definition and then another, because I'm using here and giving the possibility to use something that in functional programming means currying. We can create a wrapper for our method. So for example, I'm saying that when we will be trying to get the current state of the shopping cart, then this will be a stream aggregator. And I'm passing here as the first param, the apply method, so with the pattern matching, as you will see further on, that will define how to apply all of our events that we defined previously on our entity. And as a result, we are getting function that will take the set of events of the shopping cart event type. So this, as a result of the stream aggregator, is a method that will take a set of events and run the method as we defined above. I hope that's clear. If it's not clear, then feel free to ask question. Yeah, Martin, it's quite close to the finite state machine. And yeah, I think that this logic is quite cool. So let's think how we could use pattern matching. Unfortunately, that's one of the things that TypeScript cannot do easily, because TypeScript is a TypeScript until we run it, until we compile it. when we compile it, then it's JavaScript and dynamic language. So we don't know, we cannot provide a simple type check, like a type of, etc. So for this case, if we want to do pattern matching without the type guard expressions, then we need to expand a bit our event types, because to make that easier. So the most common approach here is that we are adding the string type definition to our events. And in this case, this will be shopping cart opened, or we could expand the product item added to shopping cart with also type. So as we see, we defined that event is a type, it is defined by its type and the data that it contains. And if we apply for all of those events those type definition and change the structure, then we could use here the event type and do a pattern matching based on string. And here we'll start using the EventStoreDB npm package. EventStoreDB provides a definition, a type definition, so you don't need to provide all your own typing to make sure that all the events are using the same structure. So let's try to see how to do it. So we can use a JSON event type, and JSON event type, as you see, looks quite similar. It allows us to provide type, data, so what we defined here, but also metadata, because events quite often can contain metadata. So for example, diagnostic information like user ID or some timestamp, or all of the things that our core infrastructure code will use. And EventStoreDB, in fact, defines two event types. One is JSON event type, and the other is a binary event type. Because in EventStoreDB, whatever type we choose, it will eventually end up as a binary data. So as I show you on the slide. And even if we are using JSON, then we need to serialize it, and it will end up as a byte array. And Node.js client does that internally, as you'll see later on. But if you, for example, like to use protobuf or other binary type definition, or your favorite custom one, then and you use binary type definition. But we will be using JSON event type, which is benefit, because then we can also use for example, built-in projections into EventStoreDB. So let's move on and let's replace all of the typing here. So we will be using, sorry, not that one. And yep, that's the one. And shopping cart confirmed. And for comment from Martin, yes, we could use implementation and use instance of. So for sure, what I'm showing you here is not the only way how you can use TypeScript with events, but that's the approach that is aligned with what we have in EventStoreDB, because type definition is quite important to how to serialize or deserialize data. And for example, then later on, we will still need to inform somehow EventStoreDB what's the type. But for example, you don't have to use EventStoreDB typing, but it will help you more to be aligned and don't create like a lot of core classes. But if you want, then you can design your own type system and then do the mapping, which is also perfectly fine. I'm just showing you the way that it's, in my opinion, the simplest one, but I also encourage you to be playing more with that. So let's change a bit this function. I will be adding here, so I will be using the event type to do pattern matching, and I also using trick from TypeScript. So by doing that, I'm making sure that if I add new event type into our event type definition, then TypeScript compiler will tell me that I forgot to use the pattern, to define pattern matching here for it. So regarding the stream aggregator, there are also different ways of dealing that. Some people say that you providing undefined at the beginning is not the best practice. Some say that it's better to define some default type, but I think that it's mostly a matter of taste. So for example, here, because our current state may be undefined if we didn't have any event being applied, then it's worth at first checking if the first event that we got is of the first event that we expect. So in this case, shopping cart open. And if we see that the current state is different from now, then we can throw some exception. You don't have to if you don't want, but it's sometimes worth to be sure that we don't have some wrong state in our event stream. And then when we are doing, as you see, we are just setting up the new shopping cart definition. So we are taking shopping cart ID and client ID from event data. Also opened at, we are setting the products item as empty array, and we are setting status to opened. And after that, we are just double checking if the current state is undefined. And if it's for some reason, it's still not defined. For example, we got a different event as the first one, then we might also throw error or return error. So just double checking if our state is correct. To make that compile, I will also define some error types. For now, we will be using just two of them, so open existing card and card not found. We will use the other errors in the future. And so let's define now, start defining the pattern matching for the rest of the events. So let's start with product item added to shopping cart. Sorry, not that one. So as I mentioned, we are using event type, and as we have this type defined, then TypeScript compiler will help us on that. In fact, if we write a case, then see we are getting the IntelliSense and some other types that we haven't yet defined here. So TypeScript is really smart in that regards. So what we are doing here is we are using spread operator. So we are taking all of the state from the previous event, and we are just replacing the product items with the new state of product items. So in this case, when we are adding new product item, then let's see how this definition will look like. So add product item will be a method here. So for product item, we are in this method, we are encapsulating a bit of business logic. So we are getting new product items. So for example, new socks or new t-shirt. And at first, we are trying to find if there is already such product item. So if we, for example, already bought the same socks, if it doesn't exist, then we are just adding this item. And in fact, as you can see, I'm also using immutability here. So I'm returning new array with the list that were already there, plus the new item at the end. If we already had this product, then there is no point of adding new product item line, because then it will be looking weird. So in this case, we will be doing some merging. So we will just take the current product, increase the quantity from the one that we got from our API. After that, we are getting new product with the new quantity. And again, we are returning in an immutable way new list. And after that, we are just replacing the product. We are just replacing that with the new state. So maybe let's just take product item from the top and just get it here. So it is in the same place as any other product items. So typically in the end, all of those related entities and methods will end up probably in a separate file, but we don't have time to create a lot of files. So we will be just coding here. And we also have some simplified find product item, which is just searching product item with the specific product ID. So let's go back to our aggregation. So we already defined what's gonna happen if we add new product item. Let's see what's gonna happen if we remove product item. Then accordingly, we are just replacing the product items with the new product items list. And let's define how remove product item will look like. So remove product item is similar to what we have for adding. At first, we are making sure that this product is already on the list. Because if someone tries to remove product that is not on the list, then probably either this is some bug in our code, or user sent a request based on the stale data. So we are just checking whether this product already exists, and if we have enough data already. Let's say that we bought 10 t-shirts. So if we try to remove 20 of them, then that should not be possible. So we are checking that here. And again, either we are returning the current item, or just throwing exception about the invariant. And then we are decreasing the quantity. If the new quantity is equal to 0, then it means that we don't have any product. We should not have any product items of the specific type. So we are just removing this product item. And if we still have some product items of the specific type, then we are just replacing the old one with the new one. So this is the functional way and how to do immutable operations on the arrays. So I hope that this will be useful for you. If you have any questions around that, then feel free to ask them. In the meantime, I will define shopping cart confirmed, which is just a simple, because we are just updating the status to confirmed and just setting the confirmation date. So nothing fancy here. So let's again discuss what we did. So we defined the structure for the apply method, which just takes the current state, event, and returns new state. And we define how to run the aggregation. So we are taking a set of events, a stream of events, and building the current state by applying event one by one. And after that, we are getting the current state, which can be basis for our business logic and all of the fancy stuff that we would like to do. So how to get events now from EventStoreDB, because we see here this is still we didn't touch a lot the event store. So again, event store allows and returns gives us possibility to use some build typing. We will see what's the typing in fact. So event type I already show you. So we are staying here that it is either JSON event type or binary event type. We could again use just the JSON event type if we if we know that we won't be using binary, so we can be more specific, but here there is no need. And recorded event is an event together with the metadata from the information that we got from the database. So let's see what it is. So it contains the stream ID for which this event is belonging. It has information about the ID, so unique ID of the event. Revision, which is the current position in the stream. So the first event will have revision 0, the next one will have 1, the next 2. So it's a, in fact, it's an auto-incremented number without gaps. It's a canonical. Then we have the type that you already know. We have some diagnostic information like when this event was created, and we have data and metadata. So those information like created, revision, event ID is something that is generated directly in event store. That's why we are using recorded event here, because it might be useful for us to have those information. Typically, we will just use the data, and that's what I recommend you to not depend on the on the metadata that are from store if you don't have to. But here we are just making the generic approach, and the types are quite smart. So as you see, it will be still aligned with what we already have. But as we updated some generic type restrictions here and changed the recorded event, then we also need to update the definition of our stream aggregation. So let's see how to do it. Let's add missing imports. And what has changed here? So we aligned that with using the recorded event, and resolved event is also is a type that it has also some other information like position in the global ordering. There is also concept of links that we won't be getting a lot here, but also information. So again, it's another subset of information from event store. And here we will be using promise instead of a regular one, because we will be making asynchronous operation, because streaming read is a Node.js type. It's a read stream, Node.js stream. So do not mistake that with event streams in event sourcing. What it does, it helps us and allows to efficient getting events from the event stream. So in fact, when we are doing such for each, then it's a wrapper for our streaming reads, and it allows us to get even one by one. Of course, it's doing some batching. It also has some options like a back pressure, etc. But shortly, it means that if you have really long stream, which I don't recommend, then we won't be loading the whole stream into the memory, but we will be just batching them and taking piece after piece, and thanks to that, reducing the memory pressure. So that's why we need to use the async await here. But besides that, there is no much difference. So we are again applying the current state based on the event that we got from EventStoreDB. And in general, that's all. So what we already have here and what we defined events. So all of the events for our shopping cart. We defined the how to aggregate the data, and we also defined how to get the current state of our shopping cart. So in fact, we can just call the get shopping cart method, and it will just load all of and apply all of the events and get the current state of our entity. So let's see if that's really working. So let's run that beast. We will define that's a weird syntax for Node.js to run asynchronous operation, because we will be doing that on the real event store. So let's define some product IDs. So we will be trying to buy some like a T-shirt from team building exercise and Air Jordans. And let's also define some IDs. So for example, client ID. So this is our ID, and the shopping cart ID, which will be like, some unique identifier. Let's use it. We will be using the UID package, which allows to generate unique identifiers, surprisingly. So if you are familiar with .NET, then GUIDs. So this will be a unique shopping cart ID. And let's define some events. Let's try to define how our stream will look like. Sorry. It's better to use dates for strings for dates if we are serializing that, because unfortunately JSON is not the greatest type of format for dates, for storing dates. Yep, let's continue. Yep, now it should be fine, I hope. Yep. So we defined how the example stream. So we will try to append all of those streams into event store to provide some basic information. And just to show you how TypeScript and VS Code that I'm using or other IDEs are great, is that if you get IntelliSense, then it will try to show you what type you have. And if you, for example, try to use some different not existing property, then you will get a compilation error, etc. So that's why I personally prefer using TypeScript instead of JavaScript nowadays. But of course, our NPM package allows you to use it with JavaScript. So you could also do exactly the same, just without types. So what's our story? So we open shopping cart, then we added pair of shoes. After that, we added 3 t-shirts. We then decided that we don't need those shoes. They are costing too much. And after that, we confirmed our shopping cart and started the process of payment, etc. And so how to add that? So EventStoreDB provide a class EventStoreDB client. You can define connection string, which should start with the prefix EventStoreDB. This is port that it's listening. Our NPM client is using gRPC underneath, so that's a technical detail. And also by design, we are secured. So in production, you should not be doing what you see here, because that disables the secure connection. If you are doing that, then then all of the calls are going through the raw HTTP. So it is fine for today, but if you want to be using that on prod or even on test environment, then you better provide the proper certificate configuration. You can find that in our docs. I won't be expanding today on that. So after that, we are defining the stream name. And stream name, just to maybe get back to our shopping cart definition, to put it together. So our EventStoreDB is using the following pattern. So at first, you specify category, and category is usually your entity name. So for example, shopping cart. then you have dash, and after dash, this is this should be a unique ID of your record. So thanks to having those categories, you can have some groupings, as you will see later on, and it's much easier to understand and diagnose what's happening. So you need to define your own pattern, but usually it's just an entity type name and a unique identifier. So we are using the stream name that we generated based on shopping cart ID, and we are calling append to stream, which again allows us to use the proper typing, and we are mapping those events into JSON event. Because JSON event, what it does, this method is generating the unique ID. It's underneath doing the serialization of our JavaScript object into the JSON, etc. So it's just a helper that enables you to just simplify and don't have to do your own JSON serialization, which in my opinion is quite useful. So after we append the event, and then we can read those events. And what's the most important thing about event sourcing in general is that event sourcing has strong consistency on writes and on reads. If you are doing append to stream, then comparing to the transaction level for the regular databases, it's comparable to serializable transaction level, which is the highest that you can get in the databases. So all of the events that you provided here will be either all appended or none of them will be appended if there is some clash. And you can also read your own writes. So that's different from the event streaming. So tools like Kafka, Pulsar, etc. Because when they are appending, then you are just producing event and you can subscribe. You cannot just read the whole stream. So that's why those tools are not aligned and shouldn't be treated as tools for event sourcing. They are about moving messages from one place to another, and event sourcing is about durable storing facts that occurred in your system. Of course, as you will see later on, Event Store also have some streaming capabilities, but we will see that later on. So to just be sure, we are just calling read stream, which will return as the streaming read, which, as I said, is a Node.js stream class. And we will be using that into our defined get shopping cart. And after that, we will try to retrieve the state and see if it's aligned with what we expect. So I'm running EventStoreDB on Docker, and that's the way how I would recommend you to use on your development stations. I wouldn't recommend that for the production usage, but locally or for CI, it's quite slim. It doesn't have a lot of overhead, so even running integration tests shouldn't be time consuming, and that's what I would recommend if you want to test end-to-end scenarios, etc. So I'm running Event Store right now in Docker. So let's see if my type definition is correct. Let's compile TypeScript. Great, found 0 errors. Cool stuff. And let's try to run our code and see if we get something in our database, if that works. Okay. Seems that there is some issue, but yeah, let's stop and see what's gonna happen. So as you see, this is the shopping cart that I added. So this is the EventStoreDB UI. So you have Stream Browser. You can see all of the streams that were created. As I mentioned, you also have, if you define the category shopping cart, then you will see a stream that will contain all of the shopping carts, so all of the entities that you added of the specific type. So that's why it's important to define the category properly. But we can check also the contents of our stream. So that's the one that I recently added. So as you see, there is shopping cart open, added, removed, confirmed. And let's see what's the data. So it's exactly the same as I defined. So as you see, there is a client ID in shopping cart open. Then later on, we don't need this this client ID because we already have it in the initial event. But we have information that we added one pair of Air Jordans. Then we added 3 T-shirts for the team building exercise. And after that, we removed the Air Jordans and confirmed shopping cart. So that means that that what I just typed is working, and we can continue and move on. So what we see here and what we learn is how to get events from the EventStoreDB and how to get the current shopping cart state and how to build from that. And but still we know that we can append event to streams, but we are not sure how to run the real business logic on top of EventStoreDB, because getting the state is great, but without having the business logic to append those facts that I just shamelessly appended from just typing the specific values is a no-go. So let's see how to do that. And let's define our command handling. I won't be using aggregates because I think that in TypeScript and JavaScript, the functional way is the go-to. So I'm just defining a function that will take command. TypeScript and JavaScript already allows us to use the spread operator here. So we are saying that we are having the command with this information. So for example, we want to open shopping cart with that ID for this particular user. And as a result, we will get a shopping cart opened event. As there are no business rules here, we just need to accept this command. Then we are just generating event. And that's the simplest business logic that you can have. Let's go to adding product item. That will be a bit more complex. So here, we are not only taking command, so for in this case, add product item, which takes shopping cart ID and product item, but we also take a set of events that we previously had. So it might be just event shopping cart opened, but it might be the whole history of adding, removing items to our shopping cart, depending on how undecided person are we. So we are getting the current state of our shopping cart. Then we are running some simple business logic. So we are making sure in this case that this shopping cart is in fact open, that it wasn't already closed. And that's the only business rule that we have here. And we are, as a result, again, we are returning event. So in this case, product item added to shopping cart. So the rule is for the first event, we are just taking command and getting event as a result of our business logic. And if it is the follow-up event, then we are getting command plus all the events that we had before. And if we have such structure like that, then it makes the code extremely testable, because we can run unit tests for this particular method, because streaming lead is a Node.js class. We can provide a mock data for that, and we can unit test easily our business logic. And we are also getting the good composition. So then let's define how to remove a product item from shopping cart. It's accordingly, we are checking if the shopping cart is not closed for some reason, and we are making sure that the product item in fact exists already and we have enough enough quantity to be removed. And if all of the invariant checks are fine, then we are just returning event as a result of the business operation. So in general, that's the simplest way to run the business logic. If we would like to inject some external services, so for example, if we are appending new event, then we could, for example, inject method here that will take, for example, the product ID and calculate the price. So it's really composable, and with this few simple composition techniques, we can get really easy and testable code. If you have any questions around that, feel free to write them. So how to get the EventStoreDB client? EventStoreDB should be done as a singleton, because there should be only one instance of the client, because EventStoreDB client handles reconnection internally, so you don't need to think about that. There is no issue here around it. And so you can just place that in some specific file and get the method that will either create event store if it wasn't yet created, or just returns that client. So how then connect this command handlers that we define above to EventStoreDB? And we can define two types of methods. One is for creation and one is for update. So let's see how the creation will look like. So method create will take event store client and handler, and by that we can define again using currying technique, or we are just making a wrapper for our domain logic. Then we can provide the stream name and command, and let's see what's the logic behind that. And the logic is extremely simple, because we are just calling this handler that we passed with the command, and as a result we are getting event, and we are storing here the result. And what's the most important in appending an EventStoreDB is that it supports optimistic concurrency. So for example, in this case, we might say that we expect that this stream does not exist, because that we expect that this event will be the initial event. And EventStoreDB, if it appears that there is already a stream with the specific name, then it will throw error. So thanks to that, we can make decision based on the current state, and we are sure that we are making those decisions. And update is similar. We again taking the EventStoreDB client, and we are taking handlers, and handler in this case takes the set of events and command, and again return stream event. And the logic is similar. So at first we are getting these events from EventStoreDB, the current state of our stream. We are calling handler method, which will get the current state of our entity. And as a result, we are getting event, which we can store again, or simplify even like that, with the append stream. The difference here is that we are not providing the generic no-stream identifier, but we are setting the expected revision. So maybe let's go back for a moment to the slides. Okay, no, I don't have it here, unfortunately, sorry. So optimistic concurrency works like that. When we are getting at first, when we are opening the screen on our UI, then we are getting the current state of our entity. And we should get also with this current state the current version of our entity. And when, for example, two people tries to open the same entity and tries to update the same entity at the same time, then the first one will succeed because we will provide the expected version that is matching the current state of the stream. But after that, the newly appended event will have the revision incremented by 1. And when another person tries to append to the stream with the obsolete revision, then EventStoreDB will throw exception or return error depending on configuration, informing us that you cannot change this stream because you are making decision based on stale data. So if someone is telling that event sourcing is eventual consistent and you are not sure if you are making your business decision on the current state, then that's not true. That's only true for read models. But for read models, we typically expecting that there might be some latency between when we run our business logic and when those changes are visible on the read model. But on the business logic, we have strong guarantees. We can use expected version, etc. So nothing blocks us. So again, getting event, building the state, running the handler logic, getting new event and storing it. And simple as that. And let's define our web application, our web API then. So we will be using Express.js. So let me add some imports for Express. And Express is the most popular and the simplest web framework for Node.js. And in my opinion, that's perfectly fine and perfectly enough to have. So because we can define our root, so let's say that we are defining endpoint with post, and the URL structure is like that. This is the parameter that we can get. So we are just saying that for post method for this specific URL, we will be creating new shopping cart. So first, what we are doing here is we are generating on server new shopping cart ID. We could, in theory, send that from the UI, but that depends on on your preferences. Then we are building the stream name. So we are adding this prefix with the shopping cart. And then we are calling method create. So the one that we defined above. So that one. So we are providing the event store client. We are saying that we will be running this specific handler for this specific stream with such data, with such command. So in this case, shopping cart ID, we don't need to do any validation because we generated that on our own. But as client ID comes from URL and from client, then we should run some basic validation. So for example, assert that the stream is not empty. Because if we do all the validations here, then in our command handling, we can be sure that our types are defined properly, and we don't need to do another validation because we can be sure of our types, because from now on, TypeScript compiler will guard us that we provided the proper typing. And let's define those basic validations. So we have like assert not empty string, positive number, we'll use it later on, and unsigned begin we'll use further on. And again, we are getting the result from our create operation, and result is in fact the also EventStoreDB append result, which may provide us the next expected revision. So when we created stream or we appended new event, then we are getting in result expect the revision of this newly appended event. And we can return that as a tag. And tag is a header that can be used and is the it was created to allow caching and to identify if we are making decision or returning the data on the latest state, or if we should refresh the cache. But it's also perfectly together with if not match tag to be used for optimistic concurrency. So we can return this newly expected version and then update our UI with this information and send it in the follow-up request. And we also returning the 201 status, and we are also returning the ID of the newly created record. So we are following the REST API best practices. So as you can see, status 201, and we are returning ID, and also location header with the link to the newly created record. We will define get endpoint later on. And let's briefly have a look on how ETAG works. So ETAG can have two formats. It is either weak ETAG, and weak ETAG is means that this value is unique in the specific scope. So the scope can be, for example, event stream. And in event stream, you don't have two events with the same revision. So we can use weak ETAG in this particular context, putting a value here with the revision. And this is just a basic validation. So we are checking whether this is a proper ETAG. We are defining methods that will get us value and parse the value from the ETAG. And also we are defining method to get ETAG from if match. We will use that in the next method, because if match is a header that should be sent in the request, and it's saying that you should update the state if it's matching the specific revision in this particular case. So we are benefiting from using from the optimistic concurrency. And let's now use it and see how we can have the full update with the optimistic concurrency. So this is not much different. We are getting shopping cart ID. In this case, we are getting it from the URL. So we also need to assert and make sure that it follows the rules as we want to have. Then we are defining the stream name, and we are getting the expected revision from the if match header. So when we open shopping cart, then we would get the revision equal to 0. When we are appending, when we are adding new product item, then we should send this value that we get previously, so 0. When we are appending new item, then we should send the 1, so the current version of the ETAG. So we can take this expected version and pass it to the update method. So this is not different. We are providing the event store. Then we are saying which handler we would like to use. And then we are saying that we are making the operation on this particular stream, and we are sending comment with the data as it is here, and also expected version. Again, as a result, accordingly, we are returning the next expected version as a ETAG header, response header, and returning status 200. For the removing product, this is exactly the same. The only difference is that we are running different handler here, and we might have different payload. And for shopping cart confirmation, that's even simpler. So we are just saying that I think that I'm missing the handler. Let's define it. For some reason, I think that I didn't define it. Let's look. Yep. Here is our confirm shopping cart method. Just make sure that we are not confirming closed shopping cart. And right now, we already have the API that allows us to provide whole operations, whole write model operations on our shopping carts. So, do you have any questions around that? Feel free to ask. The question from Arvin. What if a write relies on another write, like signing up a user and check if the mail already exists? If such a scenario, should use EventStoreDB? Yes, you can use it. However, that's not extremely specific to EventStoreDB, because in general, the convention is that if you are using the like CQRS or or even not using it, the best is to try to model your domain in a way that you are updating a specific aggregate and changing only one. That's much easier even in a relational database, and it's much easier to not have deadlocks, etc. But there are practices, like at first the best is to try to check if the modeling is correct. So if you cannot model that differently, then another pattern is a reservation pattern. So at first you are trying to acquire a log on the specific object, in this case email, and then you are appending the event. So for example, creating a user, and after that you are releasing log. However, that's a bit more complicated. But the first question that I would ask myself is it fine to make decision in this case potentially on the stale data? So you could potentially call a read model or get the event from another stream and check whether this particular stream, for example, this email already exists. And if it doesn't exist, then create. And maybe you can provide some diagnostic after that will be checking if you don't have duplicates and running some additional logic. But those things are not extremely related to EventStoreDB, but in general, it's similar patterns should be used for other key value stores or document databases. In relational database, you can tweak that by creating a unit of work around changes on multiple tables. But majority of databases like Mongo, even Elasticsearch, don't have those built-in transactions. So in those cases, you will need to use exactly the same pattern as it was. Okay, Arvin, if it would be good, I would be grateful if you could provide me information if that answered your question. If not, then I can get back to that later. And for now, I will continue and define how to run our API, because it's great that we already have this all of those endpoints defined, but how to join them together. So sorry, not that one. Yep. So we are defining a basic Node.js Express application. So we are saying that we will be handling ETAG on our own. We will be using JSON payloads with URL encoded, etc. So basic stuff. And we are just calling the creating server from Express that will be listening on port 5000. And yeah, we are just calling some diagnostic to make sure that that our server is up and running. So we could try to call it and see if we will have some information. Yeah, it's compiling, it's fine. So so we have right now the fully working write model. So let's see how to define the read model and where the streaming capabilities that I mentioned are existing in EventStoreDB. So EventStoreDB provides a mechanism that is called subscription. In subscription, we have two types of subscription. One is persistent, which allows to scale horizontally, like a competing consumers patterns, but it doesn't guarantee ordering. So for read models, we are in general recommending using catch-up subscriptions. So in this case, regular subscriptions. So what's subscription? Subscription is like after you appended event to event store, then you can get notification and then run your logic. This might be updating read model. This might be forwarding that event to some message bus like Kafka or Rabbit, etc., or sending any other type of notification or doing any other follow-up logic. For example, even like a Saga patterns, etc. And how does it work? At first, we need to know from which checkpoint we should start. And for catch-up subscriptions, we need to maintain checkpoints and store those checkpoints. So the last handled event in our end storage, because, for example, server can restart, and after restart, we wouldn't like to start again from the beginning, but from the last handled event. So at first, we can provide a generic method for loading checkpoint, and checkpoint is in fact just a position. So if there is no position, then it means that we need to listen from the start. And if there is already checkpoint recorded, then we should specify. Just you can ignore this weird syntax here. That's a old pattern where we had some kind of transactions in EventStoreDB. In the long term, this will be unified also to the single value in some next releases. But for now, let's say that we are storing the position, which is a big int, and the structure of the EventStoreDB position is that you need to provide it as a pre-parent commit. But that can be the same value, so please ignore it and move on. And we can also have some filtering. You can define your own filter, but you can have some predefined filters, like, for example, exclude system events. So in this case, it will you won't get notification based on some events that are internally published by EventStoreDB. And after that, subscription is just, again, a Node.js stream. So you can use handlers like you could use in any other streams. So for example, on data, you will get on the handler, you will get a result event, and then you can call each of handlers that you passed through this method. So you can define a subset of handlers that will be doing some kind of logic based on your event. So maybe let's define again the handler structure. It's as simplest as it can be. It just takes event and does something. So it's not returning anything. So we will be getting event one by one. All subscribe to all means that we are subscribing to all events through the database. So you could, for example, have here multiple projection for multiple stream types, etc. And you can centralize the logic here. That's why I'm doing this for each here. And so we will be defining the typical details read model. It will be equal to the read model that we know from the write model. But again, single event, same set of events can trigger and create multiple projections, multiple read models that will be fine-tuned for your needs. So for example, you can have a shorter version of the shopping cart that will only have the shopping cart ID and product items count. So like a shortened version that you typically see on the list. You can have a details model like we are defining here, and you can have some more expanded that you will be publishing, for example, to Elasticsearch to have a full text search capabilities, etc. So I will show only one projection, but same case you can do for any other type of projection. So here we will be using MongoDB, and let's define some of the Mongo related code. Nothing fancy here. So we are using Mongo client. We are, again, Mongo client like EventStoreDB should be registered as singleton. We have some options like which database we would like to use and which collection. Collection, if you are not using MongoDB, then it's like a table in a relational database. Then we have some wrapper method to simplify getting the collection. And we have some helper because we will be using string IDs, so our shopping cart ID as Mongo ID. This is maybe not the best practice, but for now it should be enough. You can optimize that further on if you'd like to. And let's go further and see how we could implement our projections. So, one moment. Yep. The first thing that we have to implement is to define our projection definition. So we are saying we will be handling all of the shopping cart events here. So we will be, at first, we have to verify and do the type check for whether this is really a shopping cart event, because if not, then it means that our projection should not be handling that. So we can add this type check. And if it's not event, we don't want to handle that, then we are just we are just ignoring this event and not doing anything. Then when we are getting the event and stream revision, we can pass it and use again pattern matching to use a specific projection logic based on the event type, because different apply methods will have potential to be optimized in the using the like a MongoDB syntax to just provide atomic updates. So let's start with the shopping cart open. At first, we are getting the shopping carts collection. Then we are just calling insert object. We are calling toObject ID, which will just say that ID of our document will be shopping cart ID. And then we are applying, so adding all of the necessary information. Then when we are adding new item, new product item, then it's a bit more complicated. So, but it's not complicated because of event sourcing, but because of eventual consistency that is in Mongo by default. So at first, we are getting the shopping cart collection. And after that, we are making sure that the current state, because we have to get the current product items to again do this merging of the product items when we are appending new product item, then we need to have the current product item state. And to be sure that we are getting the document with the expected version, then we need to provide filtering. So we are saying that we would like to get a shopping cart with following ID and on a specific revision, because MongoDB has eventual consistency, and by default, you cannot read your own writes. So even if you applied and store new information, then when you read them, then they might not be immediately visible. So what we are saying is that we are trying to get the document, or in fact just product items and revision, because we don't need more in this projection logic. And if we haven't found that, then let's retry the read. And we will be retrying that until our max retry count has been reached, or we got a document with the specific revision. And as we are expecting, and subscriptions guarantees ordering, and that will be processing sequentially events, then that normally should be just a single call. But it might be more if we have a lot of events added immediately. Here we have a small idempotency check because we can replay projections, and so delete checkpoint and start from the beginning. For example, we had some bug in our projection logic, then we can remove the read model and replay it. And here we are just making sure that, for example, our event is not older than the one that was already applied, or because we might have our projection logic should be idempotent because our handler in the edge case might be called more than once. Then we need to be sure that we are not applying the same event twice. Because in this case, if we try to add product item twice, then we would be we would have doubled items, which is not great. So we will be again trying to retry update until we have record with the specific revision. So we again saying that we are updating record at the specific revision. And here, as I mentioned, we can benefit from MongoDB syntax. So we don't need to update whole document, but just change what's changing in this event. So you can compare that to like updating only single column in the relational database. So the product item removed looks really similar. We have again the same logic. So we are getting product items, we are retrying that, and we are also after that updating the product items and with the expected revision. So we are also doing kind of optimistic concurrency here also for read model, but the main purpose is not optimistic concurrency, but idempotency check and eventual consistency. And for confirmed, the pattern is precisely the same. We don't need to get product items. It's enough to just get the revision. And after that, we are updating just the confirmation date and status. And after having that, like we defined the whole projection logic that we could merge together into our logic. So, like to merge that together, we will use the following method. Yep. So we will use we will define the subscription to all with Mongo checkpoints, and it will call the subscription to all. It will provide the get event store, and it will be loading the checkpoint from the MongoDB. And loading from the MongoDB is also extremely simple. So we are getting the again the specific collection where we are storing checkpoints for each. Potentially for each projection we can have different checkpoints. So we are just getting the checkpoint for the specific subscription, and we are, if it exists, then we are returning the position. If not, then undefined. And that's more or less how that works. And for the how to use this subscription to all with Mongo checkpoints, and how to patch it together with the with our newly defined projection logic. Then we can call this method and provide our product to shopping cart item, so our projection definition with all of those internal handlers. And the last thing that we have to be doing is, after applying we are providing the method that after we called the specific handler, then we will be storing the checkpoint. So we will be saying that once we handled the specific events, then I will store the checkpoint, so inform that the last processed event for this particular projection was the event with the specific position. And by having that, we are making sure that if, for example, service crashes, then we can restart from the last known position and call it a day. And the final thing that we will need to add is, of course, the get endpoint. So get endpoint, we also, again, we will use the Express.js, and we will define that get endpoint will just get the collection for our read model. We will be getting the exactly one result, and after that we will be also returning etag. So for example, if you are getting the shopping cart details in the edit screen, you will get the current revision, so etag, that you will after that will need to send together with the command. And then by having that, you will make sure that you are making decision based on the latest state. So of course, I defined just a simple single line definition, which is about 1,000 lines, but typically you would like to have some structure here. So how am I structuring that? So I usually have some core code. So all of the things that we were defining here, I'm putting into some dedicated files, like API has the starting server, command handling. So those methods create update that will either create new stream with the new event or append a new event after running some business logic. Then I have some set of the HTTP helpers, MongoDB. This is all of the code that is for the retries, etc. Some retry policy. Then I have code for all of the stream aggregation, getting the event store client, all of the code for subscription. But as you can see, all of that are really simple classes that have like files that have like 30 line items, etc. Then besides core, I'm usually shaping my code based on the business domain. So in this case, this could be a module or submodule shopping carts, where you can have all of the definition around shopping cart. So in single file, you might have all of the events, entity definition, and also how to get the current state and all of the command handling. You can have command in separate files if you prefer. And for the projection handling, I'm also typically keeping the details in the same, so the read model definition in the same file as the projection logic. So here I can just export the general projection logic, and I might not need to export that one. However, if I export, then I can integration test this code without even running EventStoreDB to make sure that the apply methods for projections works fine. And as a result, this is just a basic code. So I'm starting subscription, and I'm starting API, and I'm starting subscriptions. And if I try to run it, let's see. Yeah. Okay, it's getting some events and handling. And I also have Postman collection that you can find in your in the repository. So let's try to go the full flow. At first, let's try to open shopping cart. So as you see, I'm just sending the URL, and the only thing that I need is client ID. In response, I'm getting let's call it again. Yeah, 201. In body, I'm getting the ID, and I'm also getting the tag. As I said, this is 0. If I try to get this data, this is the Postman variable. So see, there is empty shopping cart with the revision 0, etc. And if I try to add again the one pair of shoes, then I need to pass as a if match the tag header that I got, for example, from get, so the one that I got here, and I have to provide it in the if match header and some body, and as a result, I'm also getting the new tag header. And let's see if that was changed. Let's see. Yeah, we have one pair of shoes. Let's try to add another one and maybe 3 more and get the current state. See, we have 5 pair of shoes. If we add like a t-shirt, then again, after getting, we will have updated version. So this sample that we did is like a fully working and complete version of the simplest event store and event sourcing application with the full flow of the write model and read model, etc. You can expand from that. If you have more read models, then you would need to just provide another handler here. So for example, if we had the list view, then we could also provide a dedicated projection, etc. So my main things and main takeaways that I would like you to take is that event sourcing is like you have full guarantees and strong guarantees around the event about the right model part. So you don't have no eventual consistency. You have the same guarantees as for relational databases, besides multi-streams transactions. But you have the most serial transaction level that you can have. The eventual consistency comes from on the subscriptions, because they are publishing notification about appended events with some latency. Usually it's quite fast, but for the read models, you typically expect to have some latency, because even databases like MongoDB, Elasticsearch, etc., internally they also have the latency. So if you are using them for read models, then you always have to expect eventual consistency. But I also showed how to deal with that. So you can use retries, you can use version that is provided by event to make sure that you have proper idempotency handling. So idempotency means that you won't be applying the same event twice. And yeah, as I mentioned, all of that you saw is already available in my Node.js samples. I will also publish link to that pull request on my Twitter account, so you can check that. It's already on my GitHub. And yeah, thank you a lot for being here in this crazy time. And do you have any more questions? I know that I took a bit longer, like 15 minutes longer than it was initially expected, but I'm more than happy to answer all of the questions that you have, so I can keep as many questions will pop up. So I already see some questions. So question, can we use it with the Cloudflare workers and durable objects? I'm not sure. I mean, I would expect so. I haven't used Cloudflare workers, but I think that they are using Node.js. So if they don't have any limitation around the gRPC, and gRPC is in fact built on top of TCP, then if they don't have that limitation, then yeah, you can use it. And a client for Deno, I don't know. I will have to ask George, my colleague that is responsible for for our Node.js client. I'm not sure what's involved in getting that into Deno, but probably it should be doable. But it's more a question of demand. So if we see that there is a demand for that and there is not a lot of work, then we can consider adding that. I know that George was playing some with Deno, so maybe that's possible. Yeah, I don't see any other questions. So thank you a lot. Thank you, Martin, Arvin. Thank you, Jordis, Darek, Jean-Paul, Patrick, for being here. That was a pleasure. If you have any comments, questions, feedback around the webinar that I did, feel free to send me, tag me on Twitter, or catch me in any other way. Or you can also ask questions on the PR, or even provide your own feedback there. And so that will be it. I hope that it showed you that event sourcing is not so scary, that you can write a full application in about only 1,000 lines that will have like a full application flow. So yeah, thank you. That will be it. Have a nice evening. Stay safe, especially if you are on Ukraine. Then just stay safe. Thank you a lot. Bye.